Inverse tangent is one of my favorite graphs ever, and I'm going to refer to, in fact, I'm going to resketch the tangent graph. The sliver of the tangent graph that we are taking goes from negative pi over 2 to pi over 2, and I knew that tangent is an increasing function. So the domain that we have chosen for this is negative pi over 2 to pi over 2, and that's going to become the range for the inverse. The range for our tangent graph is negative infinity to infinity, and that's going to become our domain. And one thing you might have noticed is that over here, if I'm going to describe this, I have two asymptotes. So one thing I can write dealing with tangent is that the limit as x approaches pi over 2 from the left of tangent is infinity. And I also know the limit as x approaches negative pi over 2, but from the right for this function is negative infinity. I'm going to change these using our understanding of limits. If I'm going to talk about inverse tan, it's always going to look like this. It's always x approaching something, but now x is going to be approaching infinity, and the function is going to be approaching pi over 2, and I'm also going to say from the left. And similarly, as far as this is concerned, I'm taking limit of inverse tan, and x now is approaching negative infinity, and the function is approaching negative pi over 2 from the right. And as soon as I write this, I know that we are talking about horizontal asymptotes, and this is what's important. Horizontal asymptotes. So if I go to graph inverse tangent, I know I'm going to have a horizontal asymptote at y equals pi over 2, and I'm going to have a horizontal asymptote at y equals negative pi over 2. I still know I have a few ordered pairs, 0, 0. This is the ordered pair pi over 2, 1. So I'm going to have 1 pi over 2 and negative 1, pi over 4, negative 1, negative pi over 4. But the other thing I know is that going to infinity, I'm going to get very, very close to this pi over 2 asymptote. And going to negative infinity, I'm going to get very, very close to negative pi over 2. So this is the graph of y is equal to inverse tan of x. And notice it's also an odd function. Inverse tan is an odd function. And I'm also going to be conscious of that when I go to evaluate. So I know that the range for inverse tangent is exactly the same as the range for sine. I need to give some answer between negative pi over 2 and positive pi over 2. So inverse tan of 1, I know, has to be pi over 4. Arctan of negative 1 is negative pi over 4. Arctan 1 over root 3, well, this is where I get confused a little bit. So I always still write down the ordered pairs. I know tangent is the y over the x. So if I have arctan of 1 over root 3, this wouldn't work. This one wouldn't work, but this one would. So I know this is going to be pi over 6. So then this arctan negative 1 over root 3 is negative pi over 6. Inverse tan of root 3, by looking at my ordered pairs, I can figure out that's going to be pi over 3. This one's going to be negative pi over 3. The angle whose tangent is 0 is 0. And as x approaches infinity, arctan x, I'm going to look back at the graph. That's going to be pi over 2. And as x approaches negative infinity, the inverse tan graph gets very close to negative pi over 2. And I know that inverse tangent is odd.